Unit 4, Learning Target Number 2. Plot, order, and compare rational numbers on a number line. Just a quick review. Here is our number line. And remember that the number line starts here in the middle with 0 and then grows in either direction. That's what these little arrows mean. It means that this line goes on and on forever in both directions. It starts here in 0. To the right, we grow larger and larger and larger. Numbers get bigger and bigger and bigger as they go this way. This way, numbers get smaller and smaller and smaller. So if we start at 0 and we go to -1 and then -2, we know that -2 is actually smaller than -1. And as we go this way and we get +1 and +2, then we find out that number 2 is larger than number 1, and number 1 is smaller. So that is our number line. In addition to graphing whole numbers on the number line, like 2 and 3 and 4, we can also graph fractions on the number line. In this case, what does the number point n represent? So here we have point n. What does n represent? Well, we've divided this area between 3 and 4 into 3 spaces. So we have 1/3 here, 2/3 here, and then 3/3 here. 3/3, 2/3, and 1/3. Now it's important to understand that 3/3 is a whole. So once we get up to 4, we've actually got one whole. We've added 1 to our 3. N represents 3 and 2/3. What does P represent then? P represents 4, and since we've broken it up into thirds again, we have 1/3. On this number line, we've got our numbers starting at 0, extending to the left, getting smaller to -1, and to the right, getting larger. What number does point E represent? Down here, what number does point E represent? Well, let's see how many slices we've divided this into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 little spaces between 0 and -1. Point E represents -0.8. -0.8 or -8/10. What point does number G represent then? G, we're going positive, so G represents 1, 2, 3/10 or 0.3. Now let's talk a bit about comparing rational numbers. Remember that rational numbers are all the numbers like integers, whole numbers, fractions, decimals that either repeat or are terminating, which means that they come to a stop here. Anything that's not an irrational number is what we're talking about. So we're going to compare some of these rational numbers. In this case, we have 0.16 and 0.76. Now, all of the numbers that begin with 0, all of the decimal numbers that begin with 0 are going to be found between 0 and 1. So 0.16 would probably fall somewhere right around here. And 0.76 will probably fall somewhere right around here. You put those together, and what you're going to find is that 0.76 is further to the right. Remember that numbers that are further to the right are larger, so 0.76 is the larger number. 3/4 and 2/5, when we compare those together, we have to think about these as fractions. So again, all fractions without a whole number fall between 0 and 1, or 0 and -1. In this case, we have 3/4. So we'll think of this as 1/2 instead of 0.5, and -1/2 instead of -0.5. 3/4, if we were to divide this up into 3 blocks, this would be about where 3/4 was. So we'll put 3/4 here. 3/4, closer to here actually. And then we have 2/5. Now, is 2/5 larger or smaller? Well, of course, it is smaller. So if we were to think of breaking this up into 5, we might think 2/5 would be right around here. So that would be 2/5. Which one is larger? Well, of course, 3/4 is larger because it's further to the right on the number line. Now we have some negative numbers. -1/2. So again, we'll put our fractions up here. -1/2, so we'll put 1 point there, and then -1/3. So -1/3 is going to fall somewhere around in here. Now understand, -1/2 is larger, it's a larger fraction, but it's further to the left. So again, it is actually smaller. Even though it's a larger number, it's a larger fraction than 1/3. 1/2 is a larger fraction than 1/3. Nonetheless, because it is negative, it falls further down the line, and therefore it's smaller. Here we have a regular fraction, that's an improper fraction, and a mixed number. When we look at negative 5/3, we can quickly think about that as what? We can think about that as 1 and 2/3. Negative 1 and 2/3, because 3 goes into 5 one time, with 2 left over, and we put that over the 3. Negative 1 and 2/3 would be somewhere, perhaps right around, maybe down here somewhere. Negative 1 and 2/3. Now, we know that negative 2 and 1/2 is going to be, again, further down here. We have to have it all the way down here. Negative 2 and 1/2 is clearly smaller than negative 5/3 because it is further to the left. We know then that negative 2 and 1/2 is smaller than negative 5/3. Now let's plot some of these numbers, some of these rational numbers, on a number line. So let's start with A. A is 5/4. We can tell quickly that this is an improper fraction because the number on top is bigger than the number on the bottom. 4 goes into 5 one time, with 1 left over, leaving us with 1 and 1/4. It's positive, so we're going to come up here. We're going to split this guy into 4 different pieces here. 1, 2, 3, 4. And we'll plot our point right there. 1 and 1/4. We'll label that 1 and 1/4. 5/12. Now 5 goes into 12 two times. The 2 left over. That gives us 2 and 2/5. So we can come up here and we could split this into 5 pieces, but I'm just going to guess and say right about here would be 2 and 2/5. 2 and 2/5. 2/3. We'll take a look at 2/3 here. Well, that's going to be bigger or smaller than 1? Well, because the number on top is smaller, we're going to be less than 1. So 2/3 would be 2/3 of the way to the number 1. So 2/3. And then last, we have negative 3/2. Negative 3 over 2. Once again, it's an improper fraction. The bigger number is larger, so we'll divide 3 by 2, and we get 1 and 1/2. But we can't forget that it is negative. So this time, we're going to go to the left of the 0. We'll go to negative 1 and then 1/2. Negative 1 and 1/2. Finally, let's take a look at a couple of small word problems. Lily walked 1.7 miles to her friend's house. So she started here, and she walked to her friend's house, and she walked 1.7 miles. At 6:30, she left and walked home. So this way she was going that way, and this way she was coming this way. How far did she walk on the way back? She also walked 1.7 miles. Now we might be tempted to think of this as a negative, but in fact it's not really a negative because you can't walk negative miles. So we have two 1.7s that she walked. So we'll add those together. 7 plus 7 is 14. Carry the 1. She walked 3, even though that doesn't look very pretty, 3.4 miles to her friend's house and back. Will joins a bicycle trip across the state of Kentucky. Kentucky is approximately 380 miles across. Will bicycles 95 miles, and then he realizes he's too tired to continue. What fraction of the trip did he travel? Well, he traveled 95 of the 380 miles. Now, we have to kind of work this out to get a simplified fraction. I happen to know that 95 goes into 380, so I'm going to divide both of these by 95. Both of these by 95. And you'll have to take my word on it unless you work it out on your own, and I highly recommend that you do. 95 divided by 95 is 1, and 380 divided by 95 is 4. So that leaves us with 1/4 of the fraction, was the fraction of the trip that he traveled. Or if you want to write it as a decimal, 0.25. And you can calculate that on your own.